Hello, I'm Mr. Bob, and welcome to my Algebra 1 video series. This video covers Chapter 3, Section 5, titled Compound Inequalities. By the end of this video, you will have reviewed methods for solving compound inequalities containing and solving compound inequalities joined with or. Finally, you will review skills for solving real-world inequalities. If you would like me to cover any of these topics in greater detail, please leave your request in the comment section below. Please subscribe to this channel if you find this video to be at all helpful. Thank you very much. Okay, definitions. A compound inequality. Two inequalities that are joined by the word and or the word or form a compound inequality. Okay, objective 1, solving compound inequalities containing the word and. Two inequalities that are joined by the word and or the word or form a compound inequality. We just discussed that in the definition. You can write a compound inequality. Let's look at it here. X is greater than, or here, X is greater than or equal to negative 5. And here's the and word, and X is less than or equal to 7. And you can write it as negative 5 is less than or equal to X is less than or equal to 7. So you put, in this case, with the and, we've stuck the X in the middle here, right? And it's greater than the lower value, the left-hand value, the negative 5, and the X is less than the 7, okay? Anyways, you can see it. So X is greater than or equal to negative 5. Well, here's the negative 5 right here, okay? And here we're saying that it's greater than. So you're seeing everything that goes here to the right. And the equation X is greater than or equal to negative 5. And that's what this is, negative 5. And X, the equal is the dot. And it's everything to the right. And then we take the next inequality and we say X is less than or equal to 7. So again, now we've got a dot on the number line here, and it starts right here, and it goes everywhere to the left, because what did we say? We said that X is less than or equal to 7. So here now you have X greater than or equal to negative 5 on the top, right up here, and you have X less than the negative 7, or or equal to 7. And when you put the two together on the number line, you fill in this bottom piece right here. And I'm going to change colors. I'm going to change that to red. So you fill in this piece right here. Okay, right across here. That's all the places that X is what? Greater than or equal to negative 5, and it's less than or equal to 7. So that's all of the pieces right here in the middle. So write a compound inequality that represents each situation. Graph your situation. All reals that are at least negative 2 and at most 4. So what is that? Okay. At least 2. So it's R. We're going to use R right here. R for our reals that they want us to graph here. And it says that our value has to be, our R value has to be at least negative 2 right here and at most 4. Okay, so that is negative 2 is less than R and is less than or equal to R, and R is less than or equal to 4. So we're going to do that. I'm going to put 2 marks on the line here. Okay, and we're going to say call this one negative 2, and I'm going to call this one 4. And we have an equal on both of those, right? So I'm going to put a dot on that number and a dot on the 4 because it's the equal to, less than or equal. And so R is, now you see it's between. It's got to be, R is, since negative 2 is less than R has to be greater than or equal to negative 2. So that means everything going here to the right. And then the R is less than or equal to 4. Well, 4 is here, so it has to be everything less than 4. So if I change this to blue, you'll see it's everything in here. Greater than R is greater than or equal to 2, and it's less than and equal to 4. How about today's temperature right here? Today's temperature will be above 32 degrees Fahrenheit, but not as high as 40 degrees. So it will be above, it doesn't say or equal to, above 32 degrees, but not as high as 40 degrees. And so not equal to 40 either. So our T, we're going to use T for temperature. So it's 32 is less than T. T is greater than 32 because 32 is less than the T, and T is less than the 40. So I'm going to put a 40 on the line. Here's 40. And I'm going to put a 32 on the line over here. And T is somewhere between these. We cannot include the 32. So we're going to put a circle around the 32 and a circle around the 40. And T is everything in between. So T is everything in here, not including the 32 or the 40. Okay, example one, check your understanding. We're going to do the same thing that I just completed in the previous slide. So why don't you take a look at these. All reals greater than -2 but less than 9. And the B problem is the books were priced between $3.50 and $6 inclusive. And what does that mean? Inclusive means include those values, the 6 and the $3.50. So I'm going to give you some time. Go ahead and you can work these on your own. When you come back, we'll do them together. Okay, I'm assuming you've stopped the video, you've worked these, you're back, and let's go ahead and do it. So the first thing I do, I look at the line and I say I have two numbers. So I'm going to put a number here and it's going to be my -2. And I have a 9. I'll put the 9 up here because it doesn't really matter where we put it, does it? It says all reals. So that means the line is solid with color. It's not a bunch of dots. Every real greater than -2. So that means that -2 has a circle around it. It's greater than -2 and it's less than 9. So the 9 has a circle around it. Okay, it's less than 9, greater than 2, so it's all of these values here in between. I'll draw like this, right? All of those values are included. And so to write it, it would be less than 2. A 2 is less than, I'll call it X, is less than 9. That's how we'd write that. Okay, let's do the next one. The books were priced between $3.50 and $6. So here's $3.50 and here's $6. Okay, and the books were priced between, and it says inclusive, so that means we're going to include them. So I'm going to just put a dot right here on this one and a dot right, because these are like piecemeal, right? Do them a little bit at a time. Here's the dots because it means inclusive on both. And then we need to know that the 350 is at the bottom side, so it's here and it's below. So now it's between, so that means we're below the $6, the books, and they're above the 350. So it means all the books fit on this line. Any price you can come up with between 350 and $6 can be found on that line. And if we're going to write it, we would say 350, and this is less than, call it X again, or B for books, whatever, is less than $6. Okay, good job. Okay, example 2, solving a compound inequality containing the word and, or the thought and. It's joining two separate inequalities. So let's solve. Here's a compound inequality. Let's solve this. -4, -4, is less than r minus 5, is less than or equal to -1, or -1. So how would we solve that? Well, first you do this. You're going to write this compound inequality in two inequalities where we're joining them by and. So we have the and where we're joining them. I put the and in right here. And when they say compound inequalities, what we're going to do is we're going to look at the -4 is less than r minus 5. And then on the other side, the other inequality is r minus 5 is less than or equal to 1. So there's two pieces joined here with the r minus 5 in the middle. Okay, so to solve them, we're going to treat them like an equation, and the only time and the inequality is going to not change directions at all in any of these unless we find ourselves multiplying or dividing by a negative 1 or a negative number of some type. When you divide or multiply by a negative number, that switches the sign from less than to greater than, or greater than back to less than. So let's look at it. We're going to start with the first one. Negative 4 less than r minus 5. Well, in order to do just like an equation, right? We're going to say negative 4 plus 5. We're going to add 5 to both sides because we're going to get to r by itself. So we get minus 4 plus 5 is less than r minus 5 plus 5. Okay? These two 5's cancel out over here, and you're left with 1 is less than r, because 5 minus 4 is 1. So 1 is less than r. And on the other side, on the right-hand side, we have r minus 5 is less than or equal to negative 1. And again, we're going to add plus 5 to both sides. And we get r minus 5 plus 5 right here is less than or equal. Here's our less than or equal right here. Negative 1 plus 5. And we combine our terms, we're going to get r, right here, r is less than or equal to 4. 5 minus 1, right here, 5 minus 1 is 4. So here's our 4. So now we have our two numbers. We have 1 is less than r, and r is remember from before, r is that variable that fills in the line, the solid line, whether it's however you want to fill it in, but if there's no gaps, no spaces, in our case, it's solid okay? So it's 1 minus 4, excuse me, 1, I'm sorry, 1 is less than r. Here's 1, and it's less than, so we're going to have a circle on it, okay? And the other one is a positive 4, and it's equal, right? R is less than or equal, so we're going to put a dot on the 4. We can go ahead and do that ahead of time. So now we have a circle and a dot. And now we're just going to fill it in. 1 is less than the r, and r is everything that we're going to fill in on the line. So it's going to be right here. I'll use red to brighten it up a little bit. It's all of this right here, everywhere in between, not including 1, but including 4. So here's our number right here. This is our inequality graph. Okay? Good. Okay, example 2, check your understanding. And you know from working with me in the past that check your understanding means I'd like you to stop the video and try these. Get out your paper and pencil and give them a try. And then when you start the video, you come back and we'll do them together, okay? I'll read them first here for you. So problem A is negative 6 is less than or equal to 3x is less than 15. B is negative 3 is less than 2x minus 1 is less than 7. And C, 7 is less than negative 3n plus 1, and that's less than or equal to 13. So go ahead and try stop the video, and go ahead, and when you come back, we'll try to work them together, okay? So I'll wait for you. Okay, I'm assuming you've done that in your back, so let's give it a try. So right here, we're on problem A. We have these two inequalities, right? One of them is the negative 6 is less than, right there, or equal to 3x. And the other side is 3x is less than 15. Okay, so we're going to solve this, and we're going to do it in two pieces. We're going to say the negative 6 part, negative 6 is less than or equal to 3x. We're going to get the x by itself, so we're going to divide each side by 3. And so what are we going to have? We're going to have negative 2 is less than or equal to x. And on the other side, and I'm going to say and, okay, on the other side, we have 3x is less than 15. So we're going to divide both sides by 3, just like we did before. We're going to divide this side by 3 and this side by 3, and we're going to end up with x is less than 5. So here's our two numbers. Negative 2 is less than or equal to x, and x is less than 5. So I'm going to draw a line, and on that line I'm going to put two numbers. One's going to be -2 or -2, and the other one's going to be 5. And then this is 5. The x is less than 5, so we're going to put I'll change the color here. X is less than 5. I'm going to put a circle on that 5. And on this side, 2 is less than or equal to the x, so it's a dot on the 2 because of the equal. And now what this is saying is -2 is less than x. X is all of these numbers in between. And it can't go any further because this is x is also less than 5. So here's our graph. Let's do the B. So we have -3 is less than 2x minus 1, and 2x minus 1 is less than 7. So I'm going to write the first one. -3 is less than 2x minus 1. And we're going to have an and over here. And this one's going to be 2x minus 1 is less than 7. Okay? So now what are we going to do? This side, we're going to take to get the x by itself, we're going to add 1 to both sides. And I'm not going to write it out. I'm just going to say it. So it's -3. -3 plus 1 is equal to -2. And that's less than 2x. Okay. 2x, we're going to divide both sides by 2. So we're going to get -1 is less than x. And on the other side, we're going to add 1 to both sides. 2x minus 1, I'll do it this time. -1 plus 1 is less than 7 plus 1. And now we have these ones canceling. 2x is less than 7 plus 1 is 8. And 2 divide both sides by 2. And we get x is less than 4. So -1 and 4, right? So we're going to put it in here. I'll change the color. Here's -1 and here's 4. There's no equal signs with the 4, so it's just a circle. And on this side, there's no equal sign with the -1x, so it's also a circle. So -1, not including the -1, is less than x. So x is everything in between. And on this side, it's x is less than 4, so it can't include the 4, so a circle. So this is all your numbers right there. Now let's do this. 7 less than -3n plus 1 is less than or equal to 13. So now we're going to get 3n by itself. So we're going to have 7 minus 1, because we're going to subtract 1 from both sides of this part, right, is less than 3n. And then we have and. On moving the other side, you have -3n plus -3 plus 1 is less than or equal to 13. So now we're going to subtract 1 from both sides, right? So we're going to have -3n plus 1 minus 1 is less than or equal to 13 minus 1. So these ones cancel. We have -3n is less than or equal to 12. Okay, so now we're going to divide both sides by -3. What happens when we divide by -3? What happens? This inequality changes. So now the inequality is going to be greater than or equal to. Okay, and it's 12 divided by -3. So the answer is going to be n is greater than or equal to -4. -4. That's this side. This side we have the 7. We're gonna move we moved the what did we do? We have 7 is less than 3, and did I write that out right? Oh, I already subtracted the 1. So 7 minus 1 is less than 3 is less than -3n. Okay? So, and this is going to be 6 is less than negative 3n. And since this is negative, we're going to flip this. I'll do it with red again. We're going to have, this is going to flip because we're going to divide by 3 on both of these. So we're going to divide by negative 3, negative 3, negative 3. We flip this, the inequality. So we get negative 2 is greater than n, because these negative 3's cancel each other. So now if we draw our line, I'm going to draw the line right here. And what do I have? I have 2, negative 2 is greater than n, okay? And n is greater than or equal to negative 4. Okay, so in this case, what do we have to do? We have to do some flipping or to think about it, right? If negative 2 is greater than n, that means, so if I draw negative 2, right, negative 2 and negative 4, negative 2 and negative 4. So if I'm saying negative 2 is greater than n, okay, that means that this is going, and it's not or equal to, by the way, it's a circle. And we'll put a, on the, oh, not negative 2. I think I made a mistake there. You have to excuse me. This is a 4, negative 4. And this is greater than or equal, so we're going to put a dot on here. Okay, and when we fill these in, if negative 2 is greater than n, okay, n, negative 2 is here, n is this way, and n is greater than or equal to negative 4. So it's all of these values right in here. Okay. I guess we could look at one more thing. How would you write this if you wanted to rewrite the inequality? We'll do the first one here, okay? So the first, let's do the second one because it's got a little more room. So now we have negative 1 is less than x and x is less than 4. So you can write that is negative 1 is less than x is less than 4. So that's another way you do with any one of these. Okay. So this one up here, you could say that negative 2 is less than or equal to x is less than 5. So I'll write it right here. Negative 2 is less than or equal to x is less than 5. Okay? Okay, example 3. It's a real world problem to solve. So it's talking about a swimming pool here, the chlorine and the acidity of the water in the swimming pool. So let's look at it. The acidity of the water in a swimming pool is considered normal if the average of 3 pH readings is between 7.2 and 7.8, inclusive. That means including 7.2 and the 7.8 are included in the range. So it's a dot, not a circle, right? Okay. The first two readings for the swimming pool are 7.4 and 7.9. What possible values for the third reading, P, we're going to call it P, will make the average of pH normal? So the average has to be in the range of what? Between 7.2 and 7.8. So if you add 3 of them together, you have to have a number that fits in that range. So they want to know what possible numbers could you pull and have it satisfy this range of 7.2 to 7.8. So the first thing we're going to do is we're going to relate the problem in words to maybe a more of a explained problem where it says relate right here. So we're going to like tell it in words which are equal to the mathematics. So relate 7.2 is less than or equal to the average, which is less than or equal to 7.8. Okay, so relate 7.2 is less than or equal to the average. That's the average of the 3 readings, which is the average is less than or equal to 7.8. So what are we going to do? We're going to say, let's write 7.2 is less than, right here, 7.2 is less than or equal to, here's the average, 7.4, 7.9. Here's these two, 7.4 and 7.9, plus the p-value that we're going to still take that reading. And the average means you add those up and divide by 3. And that average now has to be less than or equal to 7.8, and it also has to be greater than 7.2, or so that 7.2 is less than or equal to that number. So now we can solve it. We can solve for p. And solving for p, we're going to multiply each side by 3. Okay. And when we do that, we're going to get 3 times 7.2. And then less than or equal to 3 times what the average here, which is 3. These 3's here will cancel each other out. This one and that one will cancel each other. And this is 3 times the 7.8. So now we have the numbers multiplied by 3. So that what do we get? We get 21.6. 3 times 7 is 21. 3 times 0.2 is 0.6. 21.6 is less than or equal to 15.3 plus the p. Okay, all we did is we just add these two together and then add the p. So that's where we got the 15.3. 7 and 7 is 14. 0.4 and 0.9 is 1.3. You add it on, you get 15.3 plus p, and that's less than or equal to 23. 78 times 3 is 23.4, not 78, 7.8 times 3 is 23.4. So now we go ahead and simplify that, okay? And now we're going to add the negative 15.3 to each side because we have to get the p by itself. So we're going to subtract 15.3 from both. So we have 21.6 minus 15.3. We have 15.3 minus 15.3 plus p. And we have 23.4 minus 15.3. And when we do that and simplify, we're going to get 6.3 is less than or equal. Here it is, less than or equal to p. And p is what our reading, okay, it has to be that we pull less than 8.1. So if we pull a reading that's 6.3 to 8.1, it's going to make our average correct for the ratio of 7.2 to 7.8. And that's it. The value of the third reading must be between 6.3 and 8.1. And then they use the word here inclusive. That when they said that between 6.3 and 8.1 implies the circle. And then inclusive says, no, we want to include those numbers. So that turns that circle into a dot on the number line. Okay, good job. Okay, example 3, check your understanding. So I'd like you to pause and go ahead and try these two on your own. And when you come back, we'll work them together. But this is basically the same as the previous slide. So when you're paused, if you have to back up and look at the slide again, you can go for it. But when you come back to this spot, we'll work it together after that, okay? So I'll wait for you. Okay, now that you're back, let's go ahead and try these. So suppose the first two readings of the acidity of water in a swimming pool are 7.0 and 7.9. What possible values for the third reading will make the average pH normal? So same as before, we got 7.2 is less than the average, and that less than or equal to the average is less than or equal to 7.8. So what value for P does our third reading has to be a value for P here that when you add it into this 7.0 and 7.9 plus P and divide them by 3, that you're going to be between here. So we want to know what's the range of P values can you have, or do you have to have in order to get this to be true? Well, as before, we're going to divide both sides by 3. Here's the 3, multiply all sides by 3, excuse me. 72.3. Now we got the 3 times the 7.0 plus 7.9 plus p, and then we're going to divide that by 3. Okay, and the 7.8 times 3. And when you simplify this, you're going to get 21.6 is less than or equal to 14.9 plus p. 7.0 and 7.9 is 14.9. And then there's the p left. And then it's 23.4 right here. Now we're going to go ahead and do that subtraction of 14.9 to get the p by itself. And when you do that, we have 21.6 minus 14.9. We take 14.9 away from the 14.9 in the center there, which just leaves the p. And we have 23.4 minus 14.9 left. Simplify it. and we get 6.7 has to be less than or equal to P and less than or equal to 8.5. So I should say this way, P has to be greater than or equal to 6.7, and it has to be less than or equal to 8.5. Let's do the next one. If two readings are 8.0 and 8.4, what possible values for the third reading will make the average pH normal? Are these third readings likely? It's a little trick, a little going on here, right? So explain. Well, same as before, 7.2 is less than or equal to 8.0 plus 8.4 plus P divided by 3 is less than or equal to 7.8. We do the mathematics as before. We're going to multiply all three items by 3. We talked about this. And now we're going to get 21.6. You're going to get 16.4. You get the P, and we're going to get 23.4. Then we have to subtract the 16.4 from all three members. Here's where we subtract it. Subtract it here and subtract it here. Those cancel and go away, and you're left with P. And then take care of that mathematics. And when you do, you get 5.2 is less than or equal to P, and P is less than or equal to 7. And so they want explain why these are these readings likely is what they're asking, and explain. Well, what it says here in words here, no, they're not. It's not, because the readings in the range are not likely if the first two readings are this high. So your first readings were 8.0 and 8.4. It's the same pool. You take a reading, go ahead, take another reading, go ahead, take it. And basically, it's kind of dispersed evenly. It's a little different, but it's basically, well, what they're saying is if you have these high readings here in the beginning, 8.0 and 8.4, you're not going to end up with something between 5.2 and 7. It's too far away. So that you're probably not going to get this reading. So they're just making you realize that you have to be aware of sometimes you take a reading, something might be wrong that you have to look into a little bit. Okay, objective 2, solving compound inequalities joined by or instead of and this time it's or. So it's either one or the other in this statement. You'll see it. A solution of compound inequality joined by or is any number that makes either inequality true. Okay, but what you'll find out is that there's no one number that'll make both of them true. And the number you pick will have one of them be true and the other one will not be. So let's take a look at that. Okay, so directions. Write a compound inequality that represents each situation. Graph the solution. Write a compound inequality that represents each situation. Okay, that's what we're going to do here. So A is the first problem. All real numbers that are less than -3 or greater than 7. So now here's an or. Here's our or right here, or. Our real numbers that are our solution have to be less than or equal to 3 or greater than 7. Right here. So let's graph that. We have a -3 and we have a 7. We just put our two numbers on the number line. So the inequality is what, if you write it out, it's this. Our value x is less than -3 and x is greater than 7. So if it's less than 3, you don't see where it says equal to here anywhere. Okay, so it's a circle on the -3, and it's a circle on the -7. Okay, and so our real numbers that we're solving for here, I'll go to red this time, have to be less than -3. So then our solution is down here, forever to the left, and up here, forever to the right, because there's nothing to stop it. So our answer, x is less than -3. Here's the less than -3s, and x is greater than 7. And here's the greater than 7s. So here's the next problem. Discounted fares are available to children 12 years and under, or to adults at least 60 years of age. So it's available to children 12 years and under. So they include the 12 and everybody, all kids younger than that, young children younger than that, and adults that are at least 60 years of age. Okay, so it's going to include the 60 also. So that's right here. X is less than or equal to 12, or X is greater than 60 or equal to 60. And X can't be 0. Okay, because you're talking about age. If you were 0 age, guess what? You wouldn't be born, right? So you're not going to include 0. So X is less than or equal to 12. So here's the 12, and it's equal, so we're going to put a dot on it. And or, here's the or statement right here. X is greater than or equal to 60. So here's a dot on the 60. Okay, so now what do? We're going to say that X is less than 12. Well, what do we have to realize? They said X can't be less than 0, right? So here we can't. So we're going to have to put a dot here too. You can be 0. You can't even be 0. Okay. X can't be less than 0. It can't be really equal to 0 either. So it's kind of a questionable situation. But let's say that it can't be equal to 0 either. Otherwise, you wouldn't be born. So the solutions here are everything that's less than 12, but not less than or equal to 0, and 60 and greater. All these numbers this way, because it could be greater than 60. Okay, so there's our solution. So that was that hook in here that you had to realize you're dealing with age. So the solution cannot include negative numbers. It can't really include 0 because then you know, fares for children, 0, that means they're not even alive. Okay, um, so well, I can add a little bit. Now that I'm thinking about it, maybe you could if you said that it's 12 years, 1 year, so a half a year. So that 0 might include the half year. So maybe you can include, I'll include it just in case. Everything from 1, less than 1 down to 0, those are still children that are babies. I guess that would include them. Okay. And the 0 would account for that somehow. That's a tricky one. We can move on from that. Okay, example 4, check your understanding. It says write an inequality that represents all real numbers that are at most -5 or at least 3. Graph the solution. So go ahead and pause this. Try it. When you come on back, we'll do it together, okay? I'll let you pause this. Okay, we'll assume that you've got that. So let's give it a try. So what is the inequality we're going to write? I think we're going to write x, right? So I'll just say x has to be less than or equal to, because it says numbers that are at most -5. You can include -5. Here's -5. So x is at most -5, but -6 would work because x would be less than -5, right? Or at least, so that means least means x is the smallest, right? It's going to be at least 3. So, or it's less than, or x is greater than or equal to 3. So it's less than -5 or equal to -5, or it's greater than or equal to 3. So let's take a look at this. We're going to equal sign on both, so we can put on a dot on the -3 and on the -5 rather, and on a dot on the 3. And we can say that x is everything less than, that's this way, everything. And for x is greater than or equal to 3, we're going to go this way. Okay, that's the graph of that. Okay, example 5, solve a compound inequality containing or. So now we have the compound inequality, and we have it right here. So we have, let's read it. It says 4v plus 3 is less than 5, or negative 2v plus 7 is less than 1. So the first thing we're going to do is we're going to solve these like we would an equation, right? And they're going to have an or here in the middle, right? Because it says or. So we're going to solve this one for v, the one on the left. So we have 4v plus 3 less than 5. So first of all, we're going to get the v by itself. So we're going to say 4v plus 3 minus 3 is less than 5 minus 3. And these 3's will cancel, and we're going to get 4v is less than 5 minus 3 is 2. And now we're going to solve for v. We're going to divide both sides by 4. Divide 2 by 4, and we're going to get what? V is less than 1/2. Okay? Then, or we're going to go to the other side. We're going to say negative 2v plus 7 is less than 1. We have to get the 2v by itself, the negative 2v. So we're going to say negative 2v plus 7 minus 7 is less than 1 minus 7. Okay? So now we can simplify this. We're going to get the 7's will disappear. So we get negative 2v is less than 1 minus 7 is negative 6. So we have negatives here. We're going to divide by a negative now. So we're going to divide by negative 2. And when we do that, it flips, right? The inequality flips. So divided by negative 2. And this is going to be v is now greater than 1/2. No, 3 rather, excuse me, 3. Okay, so now they want us to graph it. So what do? We're going to say 1/2. 1/2 is where? 1/2 is going to be right about, if here's 3, here's 1, here's 2, here's a half. So here's 1/2. And the other one is 3 right here. Okay, so we're going to put at 3, it's just greater than. So we're going to put a dot there. Oh, excuse me. I'm sorry. Not the dot. We're going to put a circle there. In fact, I'm going to change it to red. We're going to put a circle at the 3. Okay. And at the 1/2, which is right here, we're going to also, v is less than 1/2. So there's a circle on this one. Circles on both. And since v is less than 1/2, v is going to go this way. All numbers to the left forever to infinity, negative infinity. And v is greater than 3, so it's going to be greater than 3 to positive infinity. Okay. Okay, example 5, check your understanding. Solve the compound inequality. Negative 2x plus 7 is greater than 3, or it's 3x minus 4 is greater than or equal to 5. And then they want us to graph the solution. So go ahead and I'll wait for you. We'll pause the video, give it a try. And then when you come back, we'll work them together. Okay, it's going to be 2 problems that you're going to kind of work out here. Okay, I'll wait for you. Okay, now that I'm assuming you've stopped the video, worked the problem, come back with good solid answers, let's go ahead and give it a try. First of all, I'm going to start out by writing an or right here, right in the middle. And we're going to have 2 equations. We're going to have one over here, it's inequality. 2x plus 7 is greater than 3. And over here we have 3x minus 4 is greater than or equal to 5. So let's work on the left-hand side first. And we're going to solve it like it's an equation. And of course, the only thing you have to be aware of is if you're multiplying or dividing by a negative number. Okay, so let's go ahead and solve it. So we're going to get the x by itself. So we're going to have to move the 7. So we're going to add negative 2x plus 7. We're adding a negative 7. It's greater than 3 minus 7. Now we're going to simplify. By doing so, we're going to have negative 2x is greater than 3 minus 7 is minus 4. and because these two 7s right here cancel out for completely, and 3 minus 7 is minus 4. So nothing's changed. The inequality does not change, but we're getting ready to divide by a negative 2. So if we divide by negative 2, so we get negative 2x divided by negative 2 is less than negative 4 divided by negative 2. Now, simplifying this, we get x is less than, the two negative signs cancel each other, less than 2. And on the other side, on the right-hand side, we have 3x minus 4 is greater than or equal to 5. We need to get the 4 to the other side because we have the 3 by itself. So we're going to have 3x minus 4 plus 4 is greater than or equal to 5 plus 4. So these 4's cancel on the left-hand side. So we get 3x is greater than or equal to 5 plus 4 is 9. Now we're dividing by 3 now to get rid of the 3 to get the x by itself, and it's a positive. So we do not change the direction of the sign of the inequality. So 3x divided by 3 is greater than or equal to 9 divided by 3. So x is greater than or equal to 3. So that's or, right? It's x is less than 2 or it's greater than or equal to 3. So let's go ahead and try it. So we have a 2. So the 2 is right here, and it's not equal, it's just greater than, or less than rather. So we're just going to put a circle around the 2. And the x for the right-hand side is greater than or equal to 3. We're going to have an equal sign. So here's the 3. We're going to put a dot on it. So what does that say? On the left-hand side, x is less than 2. So that means that every x is anything on this line that is less than 2. So that means all the way out to negative infinity. All real numbers forever to negative infinity. And on the right-hand side, x is greater than or equal to 3. Well, the dot says it's equal to 3. And this line here says it's also everything out here toward positive infinity because x is greater than 3. Okay? You got that? Good.